and we are going to start talking about organizing quantitative data. Now, the way that you organize quantitative data is when what we call a frequency distribution. Now, a frequency distribution is a 25-cent word for a table. Okay? And I'm a firm believer that whoever invented statistics a long time ago, couldn't make it as a mathematician, so they decided to branch out and make their own little math, and they decided to make these big words for simple things so it make their profession sound more important. And this is an example. A table is a frequency distribution. There's two types of tables. There's a qualitative table, which has categories. So write that down. A qualitative table has categories on the left. What is qualitative? Blondes, brunettes, and redheads. Okay? A quantitative table, or a quantitative frequency distribution, has classes. So make that distinction. Quantitative, classes. Qualitative, categories. Now, qualitative frequency distribution is pretty much useless mathematically. You can pretty much say there's 15 blondes, 15 brunettes, 3 redheads. Okay? That's it. That's all you can do with it. You can't find the mean or the standard deviation of it. You can't do anything with it. So a categorical or a qualitative frequency distribution is useless pretty much mathematically. So which ones are we going to be focusing on in 2.2? Quantitative, because it is mathematically, feasible. So with that, we'll move on and look at what a frequency distribution looks like. So here is data. Now, if you've got your book with you, you can look at it. I'm going to blow it up a little bit, and it's going to move it to the right for some reason. There it goes. And I don't understand that, but I can't move it. So, and move this over. Give me a second. There we go. So there is a set of data. You don't have to write it down, but if you do make a note of it, say example 1 on page 74. Okay? Example 1 on page 74, there is your data. What's the first step in, having anything to do with data? You organize it. And that's what they do on the next page. Organize your data. How many 1s do we have? How many 2s do we have? And this is a frequency distribution or a table with your categories on the left and your head count on the right. Categories on the left. Now, why did I say categories? Because these are categories. All right. Number of customers is not categories. Those are technically, yeah, they are categories because they're not classes. Okay, classes would be from 1 to 8, and from 9 to 12, and from 13 to 15. Those are classes. So these are categories. So in the category of 1s, there is 1. How many 2s are there? 6. How many 3s are there? 1, and so on. And that frequency is a 25-cent word for head count. Now that is very important because you're going to see the word frequency on tests and homework and on standardized tests. Frequency is a 25-cent word for what? Head count. How many? Okay? And relative frequency is a 25-cent word for what? Percent. You see what I'm saying? Somebody making up these big ass words. I mean, they're useless. Wait till we get to histogram and bar chart. That's even more ridiculous. But anyway, Relative frequency is a 25-cent word for something that you've been doing since the what? 5th grade, 3rd grade? Percent. Okay? Why don't they just put percentage? Doesn't sound flutesy enough, I guess. So relative frequency is a percent. Now, how do you do the percent? First, you got to get a total. How do you get a total of the frequency? Impress me. How do you get the total of the frequency? You add them all up. Okay? So the 30 or the 40 comes from adding up the head count. So you add all these numbers up right here and you get 40. And that's where the 40 comes from. And then you just put that number over 40, 6 over 40, 1 over 40, and so on. Now, of course, if I was to tell you to read the data and give me a frequency table and relative frequency, happy you wouldn't know what the heck I'm talking about. But if I told you to do a table and give me a percentage of each category, you would have somewhat of a shock. So make sure you make a note of frequency and relative frequency. Capiche? There we go, histogram. A histogram, don't write all that. A histogram is a bar chart where the bars touch each other. Yep, that's right. The difference between a bar chart and a histogram is the bars touch each other. Now, I want somebody in here to tell me the mathematical significance of the bars touching or not touching. There is no mathematical significance. It's like somebody said, well, bar chart don't sound highfalutin enough, so we're going to call it a histogram, and we can't be the same thing. So what we're going to do is we're going to take the rectangles and make them touch each other, and that's the difference between a histogram and a bar chart. There is no mathematical significance between the two. They're the same thing. And even the book tells you that the difference is the rectangles what? Now you are in college and you are reading a college book, and the difference between a histogram and a bar chart is the bars touch each other. Do you see how silly that is? But I just work here, okay? And you'll see the difference between a histogram and a bar chart later, and you're going to say, well, there's no difference. These are histograms. Oh, this is not the only cases where they use words and things that they don't need to. You grew up saying this, this, and this in K through 12, but now it's got to be called this. Academia, you got to love it. Here are two examples on page 76. So you'd write down table 10 and table 11. Okay? These are quantitative frequency distributions. And on the left, these are called classes. On the right, of course, is called head count or frequency. Now, make sure you understand these bold letters in here. Lower class limit, that's the 25, the 35, the 45, the 55, the 65. So if it asks for you to write the lower class limits down, you would go 25, 35, 45, 55, 65. That's your lower class limits. What's your upper class limits? The other side. 34, 44, 54, 64, and 74. What is the class width? Vertically subtract two lower class limit from the next lower class limit, or the upper class limit from the next upper class limit. So what's 35 minus 25? 10. What's 54 minus 44? 10. So the class width is 10. Now that will be on a test. Class width will be on a test. It will also be on a standardized test. So make sure you know those three things: lower class limit, upper class limit, and class width. So here is another thing of data. You don't have to just make a note, table 12. It's another set of data. You organize it and you put it in classes. Now, I'm not going to ask you to calculate the classes. Okay, so write that down. I'm not going to ask you that. They're going to show you how to calculate classes in the book, but I'm not going to ask you that. Because 9 times out of 10, if you are reading a frequency distribution, it either tells you what kind of classes to make or it's already done. So I'm not going to waste time. But if you want to read about it, it's in this area right here and how to do it. Okay, we're not going to do that. But here they have the classes right there. And then here's the head count. And of course, this is the relative frequency. Now, to turn it into a percentage, you got to multiply by 100. So that's 5%, 5%, 10%, 2.5%, 15%, and so on. And I'll show you how to do this on an Excel spreadsheet also. The reason I use the Excel spreadsheet is not because I want you to use it, because it puts everything on the board where you can see everything. And if I try to write it on the board, I won't be able to do it because I can't put everything on the board the same size like the Excel spreadsheet. That's why. There it is. That's how you determine the class. Well, if the class width is 10, then you know how to make but this is how you create your classes right here. So you might want to write that down, page 78, gray box. You might want to make a note of that just to read over it. Construct a histogram. I'm not going to go into that. I'll show you how to do that on a calculator or a Excel spreadsheet in chapter 3. I'll show you how to do that. I was hoping they'd put a bar chart and a histogram beside each other, but they don't do that in here. Stem and leaf plot. Write stem and leaf and then draw there's the data. I'm not going to make you write all that down, but they're taking all this data and they're putting it in stem and leaf. What you do with a stem and leaf is you find your lowest value and your highest value. Now your lowest value, I think it's going to be that 9.6 or that 8.6, New Hampshire. That's your lowest value. And your highest value, I don't know, where is it? 22.2 maybe? Somebody see anything above 22.2? I think that's it. Mississippi. Okay. So, and you take your highest value and your lowest value and everything else falls in between. And a stem and leaf looks like that. Right here on the right, that's the stem and leaf. 8.6 is your lowest value and 22.2 is your upper value. You got 121.0, you got a 20.2, you got a 19.6 and 19.9, 18.4, 18.6, 18.9, and so on. It's a way to organize your data, and you can see if you have a normal curve, this one is a little bit skewed right because most of the data is on the left up here. You have to turn it on its side, and you see that most of the data is on the left side, so it's a little bit skewed right. That is a good example. I don't ask you on a test to create one. I do ask that you can identify one versus a dot plot. What's the difference in a dot plot and a stem and leaf plot? Well, instead of numbers, you have a what? A dot. And that's the next thing they're going to ask you. There's a dot plot. So make sure you know the difference between a dot plot and a stem and leaf plot. There's one other thing that you're going to see a homework question on, and that is on something that's hardly ever used. I've been in math all my life. I've never seen a split stem used. Okay? A split stem is when you break up the sets of tens. You break them up into 5 and below, 5 and above, or 4 and below, 5 and above. So you see the 1.1, 1.2, 1.3, 1.3, and then it goes 1.5, 1.5. So those are the numbers above 1.5, and the one below, or so you have 2 ones. You have 2 2s, 2 3s, 2 4s. I've never, in 20 plus years, 25 plus years, I've never seen a, what is it called, a split stem. Again, I think they just keep adding on to the stuff. It's kind of like the person that says they're an engineer and they've never been in college, but they say they're an engineer. Yeah. Okay. Y'all ever met somebody like that? Y'all have? Yeah. They say they're an engineer and they just, you know, either graduated high school or to be an engineer, there's 2 levels to be an engineer or a lawyer. Okay. First, you have to graduate college in engineering or a lawyer or doctor. Okay. Then to be legal, you have to pass a what? A test, a state and a federal test. And then you're an engineer. But I've got a friend that calls himself an engineer, and he ain't never set foot in a college. So I'm still wondering how he became an engineer. Just hope you don't run into one that says they're a doctor. A lawyer has to take the bar exam. A doctor has to take they have to take 2 exams, I think state and federal, I don't know, but they have to take a bunch of exams. I think even nurses have to take exams. So, you know, shut up, Hubert. Shut up. Okay, split stem. Never seen it before, but it's in your book, so somebody invented it. Okay. Okay. Here is 100% test question and standardized test question. Page 84. Those 4 drawings right there. Uniform distribution we're going to go into later. I think that's in chapter 5, 6, somewhere in there. Yeah, bell shape. That's what a bell shape looks like. Skewed right. All the data is on the left. Write that down or you're going to get mixed up and you're going to miss it. And if you miss one of these 4 problems on a test, don't tell anybody. Okay? Just lie and say you got them right. Okay? Because if you tell somebody you got one of these 4 wrong, they're going to look at you cross-eyed. They're going to say, really? You got that wrong? Okay? You can't spell mom backwards or make change at the cash register. All right. So skewed left is when you have all the data on the what? The right. Okay? So make sure you know those 4 questions or 4 pictures or 4 graphics. Make sure you know them because that's a standardized test question right there. 4 standardized test questions. And it will be on my test. Okay? Okay, you shouldn't have to draw those. Okay, don't just say page 84, 4 types of curves. And that's probably the end of 2.2. Yep, that's the end of 2.2. You even got a little refresher page at the end. That's neat. Gives you a little bit of everything. Tells you how to do it in Excel. I'll show you how to do that later. And 2.3 is next. 2.3 we haven't got to in the other class, so y'all are moving ahead of the other class, which y'all are supposed to do on Thursday because that's your last day. So, and I think that's probably the last page. There we go. 2.3 is graphical misrepresentations, there we go, of data. I never claimed to be an English teacher, okay? Misrepresentations, you got to say it real slow, of data. Now, there's two types of deceptions in the real world. Those that are by mistake and those are on purpose, okay? And it's for the person to decide that is being lied to, how they're being lied to. By mistake or by, on purpose. This is where the lies, damn lies, and statistics comes in. Who said that? Anybody know? Wow, how'd you know that? Oh, I talked about it already? I didn't know I talked about it in this class. I probably talked about it in another class. I get y'all mixed up sometimes. Okay, Mark Twain, lies, damn lies, and statistics. This is where you open up a newspaper or you open up a magazine or you see something on the news and it doesn't make sense to you. And if it doesn't make sense to you, chances are there's something funny going on. We'll get into that in a minute. So these are going to be mostly pictures. So most of y'all can do these, okay? Mostly pictures. All right. Just show me the picture. Usually when you're talking about misrepresentations, there's something about the graph that just doesn't work. I told you probably at the end of the last class to make sure you look at the soccer ball first. I don't know if I told you that or not. Well, here's a graphic right here. Okay, what's wrong with this graphic? Well, first of all, the proportions aren't right. Second of all, it doesn't equal what? Doesn't equal 100. Always look for that. Usually somebody that's reputable will say in parentheses, if there's 5% missing, it'll say 5% other, or it'll say 5% did not answer, or 5% did not respond, or something like that. They're not just going to leave it out. And if they leave out a big chunk, then it's not worth the paper it's written on. Unless they're showing a breakdown of something else, like, I don't know, 94% of the people that voted for this person was blank. Out of the 94%, and then they break it up into 2 or 3 groups, then you might see a little bit of discrepancy, okay? If they take a sample, if they do a representation of a subgroup, there might be a little bit of, a chunk out of it. But other than that, next, where's that soccer ball? There we go. Now, what's wrong? Let's read it. It says right here, it says, I'm looking, by 2009, okay, there are approximately 10 million participants in the United States. By 2009, this number climbed to 14 million. Okay, so that's your data. Now, what's wrong with the picture? I'm sorry, speak up.
It's not proportionate at all. You can't really clearly see.
Exactly. How much is 14 million? Well, you would say new minus old over old. So that would be 14 minus 10 is 4 over 14. Okay, that's the percent increase. So that's not very much because 4 divided by 14, well, that's not, 5 divided by 15 is 1/3, so that's 0.33. So you're talking about a 33% increase. Everybody with me? Roundabout, okay? How many of those little soccer balls can you fit into that big soccer ball? A lot. Let's see. All the white area, that's 1, 2, 3, 4, 5. So you can pretty much fit that soccer ball into those 5. That's 5. Then 6 in the middle with that black one. 7 at the top. 8 with the 2 on the sides. And 9 with the 2 on the bottom. That soccer ball is 9 times bigger than the little soccer ball. Now, the difference between a person that knows what's going on and a person that's ignorant is the person that's ignorant look at it and go, I don't see anything. Okay, now you see. Okay? Now, I don't mean to, I'm not saying anybody's ignorant, but what I'm saying is knowledge is what? Knowledge is power. And what you do not want to be in a world like we live in right now, you don't want to be ignorant. And when you're reading an article, and the article gives you a graphic, and the graphic looks like that, you're being misled. That's why you have to read with the actual numbers, and if they don't give you the numbers, then there's something fishy going on. Okay? Now, first of all, I need to say this because some people, this is in the book. I didn't make this up, people, okay? This is in the book. This is out there. Okay? I didn't make this up. That's all I'm going to say. Next. Pie graphs are the worst because they'll just put stuff out there and then they'll say, this is the pie graph, and people will not look at it, and before you know it, it's up to 140%. What's wrong with that? Well, it's supposed to equal what? 100. Again, people will look at it and they'll go, and then they wonder why, people take their money, or knowledge is power. You've got to read, you've got to look, you've got to analyze. Or you can be like those people that can't answer simple questions on the beach or the sidewalk. And those people, good God, they're stupid. All right. I guess you can find something wrong with this one. I don't know. I won't get to the barrels. Barrels of OIL. I'll let y'all decide if there's something wrong here. I'm going to get to the barrels. I'm going over questions that I would put on a test. And like I said, this is all, there's the barrels. All right, now I want you to look at those, and I want you to do some math. Get your calculators out, and maybe do new minus old over old and see what the actual, new minus old over old multiplied by 100. That'll tell you what the increase is. And all of you should know that because that's pre-algebra and below. I mean, new minus old over old times 100. So that'd be 691 over minus 7.5 over 691 or something like that. Okay, times 100. That's the increase. Now somebody tell me about how many barrels you could put, how many of those little barrels you could put in that big barrel? I would say probably 6, maybe 8. Put 3 or 4 on the bottom and put 3 or 4 on top. So I'm saying 8 times. Somebody tell me what the percent increase is. 691 is the new, minus 7.5 divided by 691 multiplied by 100. What do you get? 99% increase, but you only got 8 barrels to go in there. So is this a mistreatment? Yes. That barrel on the right should be about the size of the whole column on the right side over here. You see what I'm saying? What's wrong with this picture? What's wrong with that picture? Well, first of all, 33% should be back here because the whole width of the whole crib should be 100%, right? First of all, 33% should be back here. And then they don't even equal what? 100. Now, we're going to get into this later, but sometimes you will see a poll, especially right now because it's election year, okay? I didn't make that up, okay? It's 2020. It's an election year, okay? I didn't make that up. And right now you're going to see a lot of polls. Look down at the bottom. There's two things that you should look for on a poll. Margin of error and how many people were actually polled. Why? Because if they're putting up a national poll and they only interviewed 100 people, that's not worth the paper it's written on. If you have a poll that's above 3%, it's not worth the paper it's written on. Okay? In 2016, during the Republican nomination, this really happened. I didn't make this up either. Okay? There was a debate coming up, and it was one of the third or fourth debates. And Jeb Bush had everybody already discounted him. He was supposed to be the nominee, and he quickly fizzled out. So the elites and the media were trying to find somebody, because heck, Donald Trump couldn't win. So they had to find somebody to lead the Republican side. Okay? Does anybody know who that fell upon? Ted Cruz. Right before the third debate, a poll came out. A magical poll came out. And that poll said that national people, out of all the people in the United States, that 52% said that they were going to vote for Ted Cruz for president. You know what it had down at the bottom? N equals 100, or it might have been 500, I can't remember. And then the margin of error was 7%. Somebody tell me what kind of poll that was. It's actually called a certain type of poll. It's a blank poll. Anybody knows what it's called? Subjective poll. Write that down. What is a subjective poll? It's a poll trying to influence you. A subjective poll is a poll that tries to influence you. Now, I didn't say which way. I just said influence. Is that good probability of statistics or bad probability of statistics? Bad. It's kind of like the news, or it's kind of like the referee, or it's kind of like the judge. Okay? The judge is just supposed to interpret. The referee is just supposed to interpret. The news is just supposed to what? Report. The polls are just supposed to what? Tell you. Not try to what? Not try to influence you. The judge don't. The judge don't sit here and go, well, this is a 15-yard penalty, and come over here, quarterback, let me tell you why I think it's a 15-yard penalty. That ain't the way it's done. If you do the statistics correctly, and you're all going to do this if you're in college and you're going to get a master's degree. Master's and above, you're going to be doing this. When you present material, you got to make sure that you took every bit of the bias out of it, because if you don't, somebody's going to what? Somebody's going to see it. Okay? Whether it's intentional or whether it's by mistake, somebody's going to catch it. Okay? Unless they're oblivious or on Kool-Aid, one of the two. Okay? And some of y'all have no idea what Kool-Aid is, but that's all right. Well, stuff you drink. Yeah, that's what it is. 52 and 38. Again, this is a good poll. What's 52 plus 38? 90, and then what does it say right here? 10% don't have a clue. Now, I don't know about the proportions. You know, you could say that the proportions are not correct. I think they're pretty close. This one right here looks like it's a pretty good pictograph or whatever they call it, graphics or whatever. So you can write this one down as a check mark. You know, there's an old saying, I don't know who brought it up, don't believe everything you what? Everything you read and everything you hear or whatever. Always have a backup and always be, you know, look at what's being presented and then say, is this feasible? And anybody that looks at these two barrels, you should say right quick, something's wrong with these numbers or something's wrong with the barrels. And since the numbers are set with data, then the picture is not correct. Okay. And that's probably going to end, well, okay, there's your pie graph. Somebody, I'm not going to add them up. I don't feel like it because I'm sitting at a 15-degree angle and I can't even make out the purple. So I'm just going to let y'all add them up. A 15-degree angle and purple on black or black on purple, I can't hardly see it. So somebody add them up, tell them what you get. Say again. Okay. Now look at the proportions. You always look at the numbers and you look at the proportions. Numbers and proportions. Looks like the proportion is correct because half would be like the turquoise and the orange. That would be like 50%. So that's about right. 36 and 11. So that's about right. So I would say that pie graph looks good. Oh my gosh, is that a picture? Is that a bar chart or is that a histogram? That's a bar chart. Let's see if we can find a histogram right quick. Because we need to be able to tell the difference. Let's see, where was the, I thought we saw one back here. Oh, those are all bar charts. There's a histogram. Okay, there's the difference. I want somebody to tell me the mathematical reason for this difference. There is none. It's just, if you want to feel like you're important, you know, when you're at a bar and you're talking to your friends, just say histogram, don't say bar chart. And say frequency distribution instead of table. And you'll sound important. All right. Y'all settle down, please. Keep quiet. And that's chapter 2. So now you are responsible for chapter 1 and chapter 2 homework. And this leaves us with chapter 3. Chapter 3 is where you start getting into 80% of your Unit 1 test. So this is where we're actually going to start doing some math. Make an informed decision. Ms. Scarborough, how are you coming with that MyLabs Plus?
I finally got it to work.
Good. What was the problem with you not being able to see what you emailed me last night? Did you change,
computers, I have Firefox,
okay,
but for some reason it said like the computer wouldn't support it. But
okay.
when I went on this morning on the Teams thing and you posted the link, it works on Teams.
Good. So, did I show y'all the Teams link? I meant the link on MyLabs Plus I put on Teams? I did? You saw it? Good. That's just something I added for your convenience. You're welcome. And that way you don't have to go through Blackboard, which half the time doesn't work. And if it does work, anything that runs through it doesn't work. So were you going through Blackboard additionally, Ms. Scarborough, when it wouldn't work?
Yes, sir.
That's what I figured. I don't understand that. I don't understand why college pushes something so much that doesn't work. I mean, can y'all help me out there? I can't figure that out. And I've been saying it for the last 2 or 3 years, and they look at me like I'm an alien. They look at me like I'm crazy. I don't understand it. It's the Russians. Okay. Okay, this right here is very important. Now, a lot of you say, well, why is that important? Because this is the basis of statistics. The basis of statistics is finding out where everything is in relation to the what? Starts with a C. Center, middle. Okay? Everything in statistics is built around the center. How far am I from the center? How far am I from the average? That's statistics. We ain't got into probability yet. We're just studying statistics right now. Now, most of you can do all of this stuff. Now, there's a couple of things you can't do because you've never been shown it. Of course, there's 1 or 2 people in here that wrote this book, but other than that, most of you, if I ask you to calculate standard deviation by hand, most of you have not done that before. Okay? Most of you haven't found the mean and the standard deviation of a frequency distribution before. Okay? So there are some things that you don't know. So most of you, I would say probably 90% of the material that we're going to go over in these, well, no, 70% of the material that we're going to go over in chapter 3, you already know how to do. And that's the mean, median, mode, range, and mid-range. Some of you may know how to find the mean and the standard deviation. And some of you may even know how to find a z-score. But that's what we're going to be going over. Okay? Determine the arithmetic mean, median, mean, mode. I don't know why they, okay, whatever. Now, I'm not gonna tell you to write all this down, okay? And plus, if I ask you what the definition of mean is, half of you wouldn't be able to tell me. Some of you would say, well, you average all the numbers up and you divide it by how many numbers you got. Yeah, that's the mathematical definition. But what is the mean? And I'll tell you what the mean is. The mean is the number that makes the data uniform. That's what it is. Mean is equal to the number that makes the data uniform. So if I have 4 grades, 72, 75, 82, 98, that looks like this as far as a curve, right? There's 4 grades, they're progressively going up, right? Well, what would make that grade, what would make that box like a rectangle? Well, that would be the average. The average would make that box. Remember that uniform distribution that we saw a few pages back? That's what uniform is, one straight line across. The average makes that line possible for your 4 test grades. So if you add those 4 test grades up and you get a number, or divide by that number and get a number, that is the number that would make your test grades uniform. Okay? Now, I don't know what they say. The arithmetic mean of variable is computed by adding the values, blah, blah, blah. It doesn't tell you what the actual definition is. The definition of the mean is the number that makes the data uniform. How do you do it? Well, you add them all up and divide by what? And that's what this fancy, funky E looks like. That's called sigma, capital sigma. Okay? Now, that is Greek letters. Greek letters means that we're dealing with the what? Population, Hubert. Yeah, I told you that in chapter 1, first day. Greek letters, mu, M-E-W, is equal to sigma x over n. Mu is the Greek letter for m. Okay? Or mu. Greek letter for mu. And that equals the population. Well, what is the sample? That's X bar. And you'll see that, but the main thing is you know the difference between the two. Now I'm not going to, there's X bar right there, same formula. Okay, I'm not going to sit here and make you do an example of finding the mean. Can anybody tell me why I'm not going to ask you to do that? Because you've been doing it since what grade? Maybe the 7th grade when you tried to find out your grade at the end of the semester. What did you do to find out your grade in the 7th grade in history? What did you do? You add up your test grades and divide by what? How many tests? Y'all have been doing that for probably 5 or 6 years. I'm not going to sit here and insult your intelligence by making you do an example right there. Now, if you want to write down this example, then page 112, example 1, it shows you how to find the mean. But I don't think I need to show y'all how to do that. And like I say, 70% of chapter 3, we're just going to be going over it for some of y'all. And the 30%, I'll show you how to do when we get to it. And I'll show you how to do it on a calculator also. And the Excel spreadsheet. Median. What is the median? Well, remember, the mean is the number that will give you uniformity. The median is the variable that lies in the middle. What's in the middle of the road? The median. Median is in the middle. Now, how is the median calculated? It's calculated using the 2 middle numbers or the 4 middle numbers, whatever. Or the 2 middle numbers or the middle number. Okay, if n, and it says it down here, and I want you to make a note of this, if the number of grades, I'm going to say grades because you understand that better, if the number of grades is odd, you just pick the middle number. You got to organize them first, put them in order, and then you pick the middle number. What if it's even? Well, if it's even, you have to pick the 2 middle numbers and divide by what? 2. Now they give you a different one. I'm not going to use that. They take the 2 middle numbers, add them together, and divide by 2. So let's do one of these. Now I'm not going to go through it. Okay, here we go. They got them in order. First thing you do is how many are there? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is odd. So you just count 4 and the middle number right here, there's your mean. I mean your median. That's how you find the median. Now, if that had been 8, you would find the 2 middle numbers and add them together and divide by what? 2. We will get to this when we're doing the Excel spreadsheet, because what I do with the Excel spreadsheet is I show you how to do everything on the spreadsheet. That means by hand, because that's basically what we're doing. And I'll show you how to find the mean and median and all that good stuff. This is just to get you started on homework. Okay. Here, 1, 2, 3, 4, 5, 6, 7, 8, 9, and you pick the middle. Let's see if this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I go to 8, 1, 2, I go to 4, 1, 2, 3, 4. And somebody take 77 plus 82 and divide by 2. 77 plus 82 and divide by 2, please. 79.5. That's how you find the median. The median is the calculated center using the middle numbers. Now, why am I making that distinction? Because the midpoint is using the range, and that's finding the middle using the range. Now, why are we trying to find all these middles? because the middle is the most important number. So that's the median. Mode. What does mode start off with? MO. What does most start off with? MO. So the mode is the one that shows up the what? The most. Okay, and they should be, I guess they're going to show it to you later. I don't know. I don't know why they're not showing mode. I guess we're going to show it in the next section. All right, look at here. Figure 6 on page 116, very important. Make sure, and I'm showing you those over and over and over again because they're going to be on the test. Whether it's a standardized test or whether it's my test. When you have a curve, I don't care where the curve is, the middle is right about the middle of the curve. Do you see where they put the mean over there on the left and the right? That's about midways on the x-axis. That's what you're going to do each time. Draw an imaginary line in the middle of the x-axis. Draw an imaginary line or a light line. That's usually going to be your average or your median. And then what do you do? Or your mean, I'm sorry. And then you look at the median. If the median is to the right, then it's skewed left. If the median is to the left, it's skewed right. If the median and the mean are very close together, then you have a normal curve. Very important right here. Not because of a test question, but because, you need to know why something is skewed right or left. And that's because the mean is greater or less than the median. That's why it's kind of good to kind of print out these sections. That way, when you come to class, you can just highlight instead of having to write and draw pictures. Or you can just write page 116, figure 6. That's what I would do. There's the mode, and you can write that down. Now, out of all the things that we're going to cover, I think the mode is the worthless one. Okay? Mathematically, only thing I can tell you why I put it on the test is give you extra points. Okay? I don't use the mode for anything mathematically, and they don't use it very much in the book mathematically. It's just the number that shows up the most. Now, does it have an influence? Yes. The 3 numbers showing up the same number, that has an influence on the mean and the median. But as far as a mathematical calculation, the mode is kind of, it's there. It's the only one that's observed. You do not calculate the mode. It's the only one that's observed. Can you have more than one mode? Yes, but they have to show up the equal amount of times. So if you got a number that shows up 10 times and a number that shows up 9 times, the number that shows up 10 times is the mode. If you've got 3 numbers that show up 10 times, then you've got 3 modes. Never put 0 as a mode, meaning there is none. Why? Because you'll have a smart aleck teacher that knows what you're saying, but they'll mark it wrong and they'll put a question mark. 0 is not even in the subset. Okay? Always put a word that says none. Nairn, does not exist, there ain't one, there ain't nairn. Whatever you want to put, do not put 0 for the mode. Unless it is the one that shows up the most. Okay? In this case, 0 is the mode. Okay? Find the mode. You got to put them in order. What number shows up the most? There's no mode. This one, 0 is the mode. Sounds like a song. 0 is the mode. Y'all settle down, please. All right. Bimodal, you can have 2 modes, you can have 3 modes. I'm not going to worry too much about that because I don't test you much on the mode except for those previous 2 questions. The ones that said 0 and no mode, that's about the extent of me testing. Here's just a summary of what we talked about. This is page 118, summary of, what section is this? 3 point what? Is this 3.1? This is a summary of 3.1 right here. Three point 2, and that's where we'll stop. Because that's where I'm going to get on the Excel spreadsheet. We're going to actually start doing some math together. Okay? Now, let me go over what everybody's responsible for. Those of you that have been doing your homework correctly, you are responsible for 3.1, 2.2, and 2.3 homework. So the way this works is, what time do we meet again? Tuesday. By Tuesday, you should have all of that work done except for questions that you send me. Does everybody understand that? That's how this works. Okay? Those 5 or 6 people that have not even touched the homework, I'm not talking about people that haven't got on My Labs Plus. You're even worse off, but you're doing okay. Just hurry up and get on My Labs Plus, okay? What's worse is the people that's on My Labs Plus, they're still not doing anything. Okay? Except for you, Miss Scarborough, you've been having trouble. All right? So, to make the long story short, this weekend, those 5 or 6 people that are on My Labs Plus and haven't done anything, y'all need to get to work. The people that are on My Labs Plus, that have not got on My Labs Plus, or had trouble, y'all need to get to work. Because y'all got 6 sections of homework, 4, 5, 6, 7, 8. 8 sections of homework to do over the weekend. Now it's doable because the first 2 sections are definitions and stuff. So that's not a big deal. All right. But before you start on 1 and 2, go over that video that I did yesterday with the 12024 class so you can get those 6 questions, because I guarantee you're going to have those same questions. Does everybody understand that? Because they're yucky questions. They're not decent questions. They're yucky. So anyway, let me go ahead and shut down the presentation and the recording. And then I'll just check the